On the bench today, we have the Marantz 2215B. She's in really good shape. Even comes with the original manual, which is extremely nice. She has some problems with the output. One really cool thing is, check this out. The original purchaser's name is Frank Kunstler. Purchased from Sanger Harris, Dallas, Texas, December 22nd, 1976. Paid $250.76. Gift. That is so cool. So cool. What's this? What do we got here? Speaker wire, copper on red, black wire with red and black connection, red on bottom, green wire, whatever. I don't know what that's for. Maybe that was a service. I'm not sure. One thing, it looks like they purchased speakers too. $160 for speakers, $155 for, I don't know what that says, BIC or B/C. I'm not sure. And then $250 for the amp or the receiver. So $565 total. This is super cool. You don't run into that very often. So this is the original manual that came with this model, not purchased separate. This has some issues with the output of the right channel from what I understand. So right now we're just going to plug it in to the dim bulb, fire it up, and see if everything looks like it's okay. We don't have any shorts or it's drawing excessive current. So let's get started with that. Also note that I do not have any speakers hooked up to the outputs at all. Nothing's hooked up to this other than the power cord. Power cord's going into the dim bulb. We're going to feed it 118 volts here in the US, and that's all we're going to do. Let's fire it up and see how she goes. Nothing. We have absolutely nothing. No power, no lights. Maybe there's a fuse blown. So next thing I'll do is I'll check the fuse. Oh, come on. The fuse looks good. Let's just check it. Nope. Fuse is blown. Yeah. Fuse is blown. Okay. Well, that's good and bad. Now it's good in the fact that we know there's actually something wrong with it. And it's bad because we probably know that we have a bad output transistor. So this calls for a 2 amp fuse. Let's see if we can find one. I think we're going to be able to find one. Well, you know that's a brand new fuse. I'm not going to bother testing it. All right, let's try that again. Attempt number 2. And we have dim bulb lit up. and we're pulling 18 watts. It's not pulling a lot. The lamps are sort of lit up. They're very dim. Let's turn outputs off. They're warming up, but yeah, they're very, very, very dim. Let's give her a little bit more juice. Right now, she's pulling 17 watts. Now she's pulling 42 watts at 100 volts. So I'm going to give her the whole 115, but she's still going to be limited. Okay, so now she's pulling 45 watts at 107 volts. Faceplate is brighter, clearly because we're giving her more voltage. We don't know why the fuse was blown. So the next thing I'm going to check is to see if there is DC offset on the speaker terminals. Let's do that now. Okay. Let's check the right channel main. And it doesn't look like there's any DC offset there. On the left channel, nothing there. Remote, nothing there. And remote right, nothing there. So we don't have any DC offset. So at least that's good. So now let's hook some speakers up to it and see if we can get any kind of noise out of it. Woo! Smoke, smoke, smoke. That's not good. It let the ghosts free. Did you see that? Not good at all. We fried something. Did not like input signal at all. Not good. Okay. Well, at least we know we have something to fix. Well, we have our main power amplifier board over here. We have our tuner over here. It's really nice. It's clean. I think our problem is going to be on the bottom. I don't see anything visibly burned. Let's flip it over and see if we can get the bottom off. Let's see if we can find any sign of failure, any visible sign of failure. I don't see anything obvious. There's definitely a problem. Okay. Whenever I'm trying to figure out something I don't know on a receiver or an amplifier, I always like to check the power supply first. I feel like if you don't have power, the correct power, the expected power to the boards that need to work, then there's no point in checking the other boards. What we're looking at now is we're looking at the bottom, and we have 3 sets of secondaries on the other side of this primary. This receiver is turned on right now, and the volume is all the way down. So what I want to demonstrate, I'm on AC voltage here, and I'm just going to check the 3 different voltages that are coming out of the 3 secondaries as they go into this power supply. So I'm going to check the yellow here. See if I can do this. And we have 57.5 volts AC. On the orange, we have 32 volts. And on the green, we have 6.46. Clearly the green is for the lamps. And I say clearly because the other 2 are higher voltages, and 6.5 volts is a perfect voltage for running the lamps. Next, I'm going to move on to checking the rectified voltages coming out of the power supply. Okay, so let's see if I can stick my leads down there without knocking the meter off. I'm not going to touch the leads together. You see that? That's conductive glue. And that's just generally not a good thing to have inside your electronics. So that's the first visible problem we've seen so far. I don't know where the smoke came from, so I'm going to plug the receiver back into the dim bulb and then fire it back up on the dim bulb, and I'm going to check the voltages coming out of the power supply and see where we stand. Okay, it's been quite a while since the smoke came out of this little Marantz. I've just been busy with other things, but I'm finally getting back around to it. And before I tackle the amplifier board, because it does have some problems, and we'll demonstrate that here in a minute, I want to first check the power supply, because I just always like to see the power supply working perfectly. So what we're going to do is measure the rectified voltages coming out of the power supply. So let's get started with that right now. First point here, we have 7.71. That's fine. It's probably lamps. Let's move over to here. Try not to short anything out. And there we have 51.3735, somewhere in there, 51.3. And then we jump over here, and we've got 33. And I'm not sure this is an out. Yeah, 33 there also. Before we continue with the power supply, let's take a brief look at the overview of the entire receiver. We have the power supply down here in red, and we can see that there are 3 jumpers coming off of that power supply that have 33.7 volts, 8, 10, 11, and 12. They're all ganged together on the schematic as you've seen in the previous shots. We have 14, which I didn't measure in the video,
But you can see that 14 is actually going up here to the AM/FM tuner board, and that board actually gets two different voltages. It gets 33.7 to jumper J122, and then you can see that the 33.7 goes to the tone preamp. It's not prelamp, that's typo. It's a preamp. And then the phono amp gets 33.7, and then the main power amp gets the 51.3. So that's where the voltages are going, and we'll come back to this schematic later.
Okay, so those all look fine, but that doesn't mean that the power supply is fine. So what I like to do is also check to see how much ripple is coming through or is getting through the rectification process. So we're going to check that right now as well. Okay, so now I've got DC voltage showing on top and AC voltage on the bottom. And we're going to go ahead and start measuring that. All right. On this 50 volt rail here, we have 51.25 DC and 49, 58 millivolts of ripple, somewhere in there. This line over here, we have 7.7 DC, and we have over 300 millivolts of AC. That's not great. This line over here, we have 33 volts DC, and this one has 12 millivolts on it. That's fine. Let's go back to this 50 volt rail here. My hand's probably in the way, but there's not a lot I can do about that. So I had 250 show up. I think that was an anomaly. So yeah, 50 millivolts there. I'd like to see a lot more, a lot lower value there, something along the lines of 10 or less. So that indicates to me that the capacitors are breaking down in the power supply and they need to be replaced because ripple's not great. And so before I attack that before I attack the amplifier board, I'm going to service this power supply. So we will make sure that we have clean power going throughout the rest of the amplifier. All right, so what I'm going to try and do is get this conductive glue off of the power supply board, and I'm going to try three different things. I'm going to first try this Goof Off Pro Strength remover. It says it removes adhesive, glue, and all that. I figured, well, I have it, why not just give it a shot? And then the other two things are acetone and isopropyl alcohol. Isopropyl alcohol I started with, seemed to do okay, but seemed to take a long time. So we're just going to try some of this Goof Off first and see how that gets on. And last ditch effort, we'll just use a razor blade to remove that stuff. All right. Seems to be working better than the isopropyl alcohol did. Not going as quickly as I would like. Let's see if I can just shape that off there. Shave. I don't want to scratch the PCB. And I'm not left-handed. So trying to do this and not put my hand in front of the camera is impossible. Scraping it with a razor blade doesn't seem to want to work either. So I'm just going to keep working at it with this Goof Off stuff. But it does seem to be working somewhat. It's hard. Glue is really hard. I might end up pulling this board out and putting it in the ultrasonic cleaner. I don't know. We will see. It's working. I think it's definitely dissolving the glue, but it's taking a little bit of time to rehydrate that glue. It's so dried. I think too long. And it seems to work very well. Probably a combination of this goof off with a plastic scraper would be much quicker than a Q-tip. You can probably see the little remnants there of the glue. All right, this goof off stuff seems to be working quite well. But the combination of the screwdriver tip and the goof off is so far the best. So I'm going to continue a combination. I'm trying not to get any of this stuff on the dial string. I'm not putting any pressure on the screwdriver. I'm just dragging it across the surface, just clipping that glue. Now let me just vacuum it up a little bit. Okay, that did a decent job. See if I can drop that on there. Got lucky with that one. Okay, I'm not going to make you watch all of this, so I'll bring you back after it's done. Okay, after quite a few Q-tips, I think we've gotten all of the conductive glue off the board. It looks much better. I cleaned it off with isopropyl alcohol as well. So it looks fairly good. I still am on the fence about pulling it out and putting it in the ultrasonic cleaner. So I'll have to make a decision about that later. But for now, all the glue is off that board. Okay, so the main rectifier diodes are out, or the old ones anyway, and now I'm just going to clean up the board a little bit. All right, we are going to replace the old diodes with these new diodes. And that's pretty straightforward. We're just going to use these old bend points to bend the new ones and put the spacers back on and put them back in the board. Okay, so I just used a pair of needle nose pliers, bent these down just like the other ones, and we'll just get those shoved back in the board in the right way, which is very important. So sometimes the PCB does not have the correct layout on it, but this is a Marantz, and generally they're always spot on. You can see that the diode itself has a little gray line on the end, and that line, it lines up with the line on the triangle is pointing to. So what you wanted to do is make sure that you have the diode with the line matching with the same way. So as you can see, the next one's going to be turned, the next two are going to be turned the opposite direction, so the silver line will be on this side. And just like that, those new 4 are in. Now there are 2 more on the end here. I'll probably replace those as well, but let's get these soldered in first. All right, I'm not a fan of bending leads. I like to solder them in if possible, and then cut the leads. It's just easier on the next technician, whoever ends up being in here, to desolder. This is hard to work around the camera. So now that I have one set in, I'm going to lay that down so I can solder from the top. It's just easier for me. Let's get those legs clipped off. All right. Good enough. Well, I probably should have been paying attention a little bit closer. These are all in. I've cleaned up the board a little bit. These 2 right here I'm going to replace. I didn't notice there was another one over here. These are just regular smaller diodes. But then down here at the bottom, we have H809, which is a Zener diode, and I don't have any Zener diodes at all in stock, so I'm going to have to order that. But for today, I'm just going to go ahead and replace these other 3. I think those are 1/2 watt diodes, and we'll be done with that portion of diodes for now. So the old capacitor, this main filter capacitor that goes here, was a 3-pronged capacitor. This 3rd leg was just to add additional support for the capacitor itself. The new snap-in capacitor only has 2 leads on it, but it is the same size and it will fit, but it will require a little bit of a bodge on the backside. It'll fit between the these 2 closer terminals, but it will not fit between here. So what I'm going to end up having to do is jump a wire from this hole over to this hole, and yeah, so that's how it's going to work. And I was wrong again. The I did not even flip the board over to look, but both of the other terminals are connected to the same trace, so I don't need to run a wire from here to here. That's perfect. So here's the positive, here's the negative. So I don't like this, so I'm going to sort of put some UV solder mask on that and try to get that looking a little bit better. I might mess it up anyway. Okay, so I'm using this, I don't know how you pronounce it, but it's basically just suitable solder mask. This is where it says suitable for PCB/BGA repair. Hope you can see that. So just plain UV solder mask. Just going to try and put some on a swab. Well, it's not the prettiest, but I guess it will have to do. Well, here's the plan. I'm going to have to wait until some Zener diodes come in because I want to replace this Zener. And I don't want it to be difficult to get in to replace this Zener, so I'm not going to replace or go ahead and install the new cap here. So what I will do is go ahead and install the rest of these caps because I don't need access to anything else in here beyond right now. So we've already replaced everything that needs to be replaced on this board. So let's do that. Okay, so I'm going to start with the C808 and C807 right here because these two are exactly the same. The spec calls for a 220 microfarad at 50 volts, and I'm going to install a 220 microfarad at 63 volts. It's a Nishikon UPW series, specifically made for power supplies. So let's get that started. Positives on the downside. Long leg, positive. Short leg, negative. Oh, get in there. All right. Okay. Positive down. Get in there. Okay. All right. Okay, I'm going to bend this top lead for a second so it'll hold it in place. Then I'll bend it back out because I can't reach around and hold it, and I don't feel like taping it right now. Maybe a little more. There we go. Bend this one back out. Good. This one needs no support. A little more on this one. That looks good. All right, next up we have CO804 and 805. These are 330 microfarads, spec'd out at 50 volts. We are going to replace them with some beautiful blue, what are these, Chemicons? Yeah, these are Chemicons. 8,000 hours. 8,000 hour caps at 105C. Good looking caps. All right, same drill. Ooh, these legs are a little thicker than the last ones. I'm gonna have to work on that. Took a little bit of work, but I got them in there. Let's get them permanently in there. All right, the last one we have until we, get that Zener diode in is C810, and this is spec'd out for 470 microfarad at 16 volts, and we are going to replace it with a 470 microfarad Nishikon at 25 volts, and this is the UPM series capacitor. Little brown guy. There's going to be a lot of color on this board when we're done. And positive, it looks like to go to the right. Can get that in there. Maybe. Maybe not. Okay. Good. Only two components remain on the power supply, and that is this Zener/Zener diode right there, and then capacitor 806, I believe, right next to it. And I haven't put that in yet because it would make my life harder to put that the new Zener diode in. It would make my life harder to put the Zener diode in if it were there. So let's get that pulled out, replaced, and then we'll put that cap in and test the power supply. That was a bit of a struggle, but I got it in there. The legs on this diode are thicker than the legs on the older diode. Maybe the older diode has been working out more, I don't know. The last capacitor on the power supply is spec'd out as a 220 microfarad at 16 volts. I'm going to put in a 220 microfarad at 35 volts. And this is the Nishikon UPW series capacitor. It's upside down, but you get the idea. 220 at 35. So positive to the right. All right, let's get that tacked in. Don't hit the red wire. Don't hit the red wire. Don't hit the red wire. Damn it. Darn it. Okay. Let's make sure that's sitting flat. It is now. All right, let's clip those leads. See how far this will fly. Might flee right back into the receiver. Well, this is an interesting little tangent. So I have my negative meter of my multimeter attached to ground. So if I touch my, and I'm sitting in continuity mode, so if I touch the case, you can see it works just fine. If I touch the screw down here, see that works. This lug works just fine. Follow that right down here to this outlet or this connection. Nothing. There's nothing. I get nothing in there. So, what's in here that's not making connection? That is the $20,000 question. Well, I pulled it out and look at that. It's a resistor between here and ground. Maybe I should look at the schematic before cutting stuff out. Okay, so I have the amplifier plugged into my dim bulb tester. My dim bulb tester plugged into my variable isolation transformer. And I've set my variable isolation transformer to limit a current or trip the current if the current exceeds 750 milliamps. So let's go ahead and turn the amp on. And we have lights. So let's test the voltages coming out of the secondary of the transformer. And I think that should be these two. I don't trust myself not to slip and short something out. Let's test that there. There we have 7.75. Okay. And I think 802 and 801 are next. And we have 38.25 there. And on this last one we have 68.75-ish. So those all look good. Let's switch over to DC and see how our rectification process is working. Okay, so let me switch over to a ground point, and then on jumper 814, which is this one here, we should be getting 10, and we're getting 10.1 exactly. Okay. The next test point is 813, and that is here. And we're getting 14.8, and that should be 14. That looks good. The next test point should be 8, 10, 11, and 12, which are all the same test point. See if I can do this without knocking something over. Okay, so 811 is over here. And we're getting 32.57, and I believe we are supposed to be getting 33. The last test point is 808, which is buried right here in the middle. So, see if I can get to it. There it is, and that is reading 51.36, and I think that's a 52. We're supposed to be having 52 come out of there. Therefore, those voltages are looking good. So let's check the ripple on these points. So on the 808 we just had, 4 millivolts. Four millivolts. 3 millivolts. Those all look great.
And that brings us to the end of this part 1 video on the Marantz 2215B. Thank you for hanging around for the entire 45 minutes, which is probably way too long. If you like the format and length of these videos, please let me know in the comments below. If there are any things you didn't like, please let me know that too. Part 2 of the 2215B series will be coming soon and will be focused mainly on the main amplifier board. Don't forget to hit that like and subscribe button on your way out. Have a blessed day.